All right, so this is 6.2 notes, last section of Unit 3, and our focus is areas under the standard normal curve. So you'll recall on Friday we took all of our normal curves, and through using this formula, and we'll write it in here, z equals x, which is any of the observations in our data set, minus mu, which is our population mean, divided by the population standard deviation. Right, so that's our z-score formula. So we can now, because we have the standardized z-curve, determine the percentage or probability for a normally distributed variable. So we're going to read through these steps, starting with Madeline.
Step 1, sketch the normal curve associated with the variable.
Shade the region of interest of the markets, eliminating x values.
Yes.
Find the z-scores for delimiting x values found in step 2.
Use table 2 to find the area under the standard normal curve delimited by the z-scores found in step 3.
Nice. So this is table 2. This is for you to keep, so you can put your name on there, and you're going to want to keep it. The next copy you get won't be on this fine sky blue cardstock. So this is the table of values that we can use to calculate any area under the standard normal curve. And you can see, looking down, on one side, we have all of the positive z values. And you notice the picture here has a z placed kind of arbitrarily to the right of 0, because that is where all the positive z-scores would fall. Notice also the lowest z-score on the positive side is 0, and then the highest one is 3.99, because the hundredths place is actually listed in the row above. So you have the up to the tens place on the column, and then you would scroll over and find the hundredths place. So 3.99 is the highest value. When you flip it over, you can see this arbitrary z value to the left of 0, which indicates any negative z-score. And then in our column again, you see all the negative z-scores, and then the row above goes to the hundredths place. So our lowest value is negative 3.99. So it's positive 3.9, negative 3.99 to positive 3.99, which is even beyond the 99.7% of the data we know exists between negative 3 and 3. So let's take a look at some examples here. So in the first example we have, we'll be talking about the area to the left, which is the standard. When you look at the shaded region in this little picture here, it's to the left. So if we're just looking up the value, it's assumed to be to the left. So we look up 1.23. So we go to the positive side. That's one of the tricks. Sometimes people get into it and forget to look at the negatives or the positives, so pay close attention to whether it's positive or negative. And you go down to 1.2, and then over, find the 0.03, and then you have to match them up. You can see we get 0.8907. So the area to the left is 0.8, I did it, hold on, 1.34, what is it?
8907.
I lost it, thanks. 0.8907. That's the area, which is associated with the probability of finding an observation in that shaded region. So it would be an 89.07% chance that we would find a data point in that region. Next, finding the area to the right. So if you recall from Friday, from our notes, when we're talking about the standard normal curve, we have 0 in the middle, just like you can see in all of these. The area under the entire curve is what? Do you remember? 1. So if we go to 0.76 on our table 2, 0.76, 0.7, 0.7764. So then that value is representing this area. So the area 0.7764 is the unshaded region, since the value on the chart is always to the left of the z-score. So then to find the area to the right, we would just do 1 minus that number, which you can see is done for you right here. 1 minus 0.7764. So that area then to the right is 0.2236. In other words, about a 22% chance that the observation would fall to the right of 0.76. There's 3 different possible ways to calculate the area under the z-curve, and the last way is finding the area between 2 z-scores. So between 2 z-scores. So to do that, we look at both of the z-scores, find them in the table of values, take their areas, and we'll subtract them. Okay, so first we'll find negative 0.68, negative 0.6, and then there's 8, 0.2483. So that means right in here, this area here is 0.2483. And then we find 1.82, that's positive, so we flip it over, 1.82, 0.9656. So that means that this entire, from this point, all of this to the left is 0.9656. So you can imagine it makes sense then to just subtract off the 0.2483 from the 0.9656 to get just the region that's shaded in between the two, which is what they've done here. So the region, the shaded region between the two z-scores is 0.7173. Now we'll do a couple examples, a little bit of practice here on the back. So far, all the z-curves have been drawn for us. Again, in number 6, they're done for us. And we're going to number these just for the sake of reference. So this is going to be 1A, 1B. So these are both shaded to the left, right? So you'll follow, that's the easy procedure. You just look them up to find the area. For 2A and 2B, shaded to the right, that's where you'd have to subtract from 1. And then 3A and 3B, that's where you have to find both of the areas and then subtract. Can area ever be negative? No. So it's a measurement. Measurements are never negative. So you're always subtracting the larger minus the smaller. If you get mixed up, it can't be negative. So go ahead and try those out.